Hello, this is a video on aspects of a project finance model that will start to get a little trickier. This is essentially where we left off the last time. What we're going to work on is how much debt can really fit into this project through looking at the debt service coverage ratio and other statistics. The first thing we can do, however, is compute a couple of outputs from the model. Now, the outputs essentially all really come from the cash. The outputs all essentially come from the cash flow statement. That's given the idea that project finance is really all about cash flow, not about earnings, not about PE ratios, not about return on invested capital. They all come from this one little end of cash flow statements. We computed equity cash flow. I'm going to I'm going to just restate the project free cash flow. And the project, that number is a number we already computed. Okay, now if you want to verify the model and start checking things a little bit, come on, where did I put that? There's free cash flow right at the end. 10,000, the minus 10,000. What? Shift Control R. I'm doing this video in the dark. If we put in a 0% financing and get zero debt, then the equity cash flow should just be the same as the project cash flow, and there's a very slight difference here for this working capital adjustment. Let me review that in just a minute here. Now, if you then would want to get the IRR on the free cash flow, since we have a analysis that has some monthly periods and some semi-annual periods, you cannot use the regular IRR and just raise it to the 12th power or the 4th power and all that. What you have to, this is a area when probably use of the XIRR is helpful. The XIRR takes a group of cash flows and then also takes a group of dates and computes it. And if we compute the XIRR for the, let me do that one more time, for the free cash flows rather than the project cash flows, we should get the same answer. Shift Control 5. Okay, now let me just review the working capital adjustment for a little bit. Since we had a big upfront working capital in this analysis, we could put a little reserve account for the working capital as part of our costs. We need to pre-fund the working capital. I could call that add something like pre-funded working capital, because after we start the project, we're not going to have enough cash flow, or we're not going to receive any revenues. We're going to have to make some expenses, and we're certainly going to have to pay some interest and debt repayment. And if we have all that big working capital, it's going to cause a problem. Now, what we can do then is, when we take away the working capital, we can add back the use of that little pre-funded reserve. So in this case, we take it away and we kind of add it back. Okay, and then we'll put it on the balance sheet and make sure everything works. So that's the little adjustment for working capital. Here's the amount you have to pay to pre-fund it, and then you get a higher cash flow at the end because this one has a subtraction for all the working capital. All right. Then now let's compute some debt statistics. Let's compute the DSCR. Okay, and to compute the DSCR, we just again look in the cash flow statement for CFADS, and we compare that to the debt service, and then we get our DSCR ratio per periods, which is really per semi-annual period. Okay, and just look straight up to the cash flow available for debt service, get the interest plus the interest plus the repayment. And why don't we put an if statement that as long as this is greater than some small number, let's make it the top divided by the bottom. Okay, and the false is a wonderful thing in this case. It's really wonderful because we kind of discussed that false is a lot like zero, but we always have false. It's not zero in terms of the minimum. You take the minimum. I wonder what will happen here. They're all false. Well, this one gives us zero. If we put a little bit of debt in here, okay, oh, it's a lot. Okay, then we now you see that it did not take the difference to be, it did not take the falses to be zero. Instead it just ignored the falses in the calculation. Now, of course, we get a higher equity IRR than we get a project IRR because our interest cost is less than the overall project IRR. And okay, what we'll do now is we should really reconcile some of the IRRs and the DSCRs. Now, why don't we first compute something called the PLCR, which sounds fancy, but all it is the PV of the debt service. Now, and I'm sorry, the PV of cash, CFADS, and PV of debt service. Now, the PV of the debt service we'll show you here, is going to equal the loan size. So we can also just strictly take the PV of the debt service. Now, we could, in this case, we have constant interest rates, but I'm going to put a PV factor just in case you wouldn't have constant interest rates. And the trick here is to put an equal 1. And we'll take that and multiply it by 1 plus the interest rate. And where can we find the interest rate? Excuse me. Here's the interest rate. And we don't begin doing any present valuing until the project is being paid off. That means until I don't have an operating switch, so I just have a construction switch. So why don't we just put not the construction switch, and then put another bracket. Okay, shift control 1. What do I do? Oops. And okay, so we have nothing until this period, and later we'll compute the right now we can compute the total PV of the debt service as simply the okay, I'll put some product here. So, and here's the nice trick with this one. You put some product, and you can go to the cash flow available for debt service just in this line, and you can divide it. It's not kind of in the Excel things. It's not obvious, but it works like this. And if you wanted to, suppose we could put equal NPV, and we could go up to the discount rate for the debt and have it here. But again, find the discount rate. Let's find it over here somewhere. Oops, there. That would be fine. And then let's take the cash flow available for debt service and only take the stuff just right at the start. Okay, just right here. And we get the same number, okay? But that's a whole lot less flexible, I think, than the manner in which we just computed it now. Now we could do precisely the same thing by taking some product. Okay, and we can go to the debt service and take that number and divide that by the, oh, come on, by the, and we get exactly the same debt that we input. Did you see that? So instead of doing that, why don't we just get the total amount of debt? Now, I haven't really kind of explained, so the PLCR ratio, okay, is just this divided by that, okay? I haven't just described really how to use it or what to do with it in the future. And actually, you know, if you wanted to compute this going forward, I'm not even going to talk about that because it would be a little bit trickier. I think in that case, a function would really help. Really do. You could make a bunch of lines and make it all kind of complicated, but you'd have to keep going forward in the model, and it could lose some flexibility. So now let's compute the loan life coverage ratio. This was the project life coverage ratio. We don't need a PV factor. We need the CFADS over the debt repayment period. And then we take the PV of CFADS over debt repayment period and compare that to the loan size, and it's really at COD. I should have been careful to say that, and then we can get the LLCR ratio. Okay, the CFADS over the why did I go too high? That's simply the cash flow available for debt service, and luckily we have our nice little switch right up here at the top. Debt repayment switch. Okay. Shift Control R, and now we can get the the same thing with the sum product. It's probably not really necessary to say that, obviously, the sum product. And we can just take this whole one and divide it by the PV factor that we just computed above here. And we get a smaller amount because obviously we have smaller debt service. And we can take that compared to the loan size and compute our third ratio. Now, why don't we also compute the average debt life? And the average debt life is if you had a loan that had let's see how we'll do this. Let's make the loan here a level loan being 10 years. Now, if the loan is just 10 years, and if we repaid the whole loan in some sort of bullet payment at the very end, then you gotta remember that balloon versus bullet. Bullet is just a simple repayment at the end. Balloon could be something where you haven't even provided for it in the cash flows or something. But bullet repayment right at the end, the average life would be 10 because the loan would be outstanding for 10 years. With a level repayment, it should be something like 5. With sculpted repayment, it can be all sorts of different things. So let's make that calculation. Okay, here's the trick to computing the average debt life. We'll first compute the average balance of permanent debt. I'll spell that. And then put average of the. Come on. Put the average of the opening balance and the closing balance. So I've tried it with the closing balance and the opening balance. It seems to work with the average. Now, once you have that, what we can do, the trick to getting the average debt life is you can just take the sum. Look at this. This is in the very first period. I'm not sure. I think that still works. Okay, and then let's take the to get the debt life is the sum of the balance, divided by the initial amount. And here's what we can do. I think, let's just use the sum if here. So when I just said this, I was wrong. If we put sum if, and here's the trick with the sum if. I think we've done this. I don't know if we've done this enough, but we should. The sum if together with a switch is a kind of nice thing. So we just sum if it's true, and then we sum if the average balance of the debt. Is the sum if one of your favorite commands now? I hope it is. And then we take the initial, which was the debt over here, and then why don't we compute the average life ratio? Average life. Oh, I didn't mean to. So this is this one divided by this one, but we have to also remember this would be the average life stated in semi-annual periods, so we have to divide it by 2. And it gives us exactly 5, and that's the answer it's supposed to give us. Now, before we move into the next subject, I think we should compute the up here after we computed the project IRR and the equity IRR. I think we can compute the debt IRR. Now the debt cash flows we have to be careful with. So debt cash flows, it's just going to be like any other IRR. We'll take outflow for draws, and this has to be the real amount you actually, the debt holders put in, remember. Interest paid, not interest capitalized during construction, interest paid. And then we can put repayments. So let's see if we can get the outflow for the debt draws. I'm going to state that as a negative. And remember, we put it in the debt funding and also in the construction debt. I don't think it really matters which one we take. Okay, and then we have the interest paid. Let's first take the interest paid during the construction. And it's the interest during construction minus the interest capitalized. If we capitalize, our balance becomes bigger and then we have to repay more debt later. So we have to be careful with that. And let's add to that the interest during the construction period. And then we can put the repayments. Our repayments are the, obviously, permanent debts. Okay, is this the repayment line here? Okay, so now our total is all equal. So that's our total cash flow. And why don't we, I didn't. Okay, we cannot ever forget the fees paid. Okay. Alright, and they might be capitalized as well, so we have to be a little careful with this one. So let's make sure when we add the fees that this is all going to work. And we press Shift Control R, and now we can compute the debt IRR, and I'm going to call that pre-tax. Okay, and that's going to be the same XIRR as we do with everything else. We put this one up and this one up. And we get a 2.52. Interesting, rather than exactly the 2%. Stop just to see if I made a mistake. Okay, sorry about the break there. I think that's okay because the that gets into this whole compounding business with the interest rate. The final thing we can compute here is it's about the final thing to compute is how about we'll put the tax effect. Okay. And we'll put tax effect of interest and IDC. Okay, and what we do here is we put the tax deductions from debt, and those tax deductions from debt include a couple of things. The first thing they include is the interest, but in addition to that, it includes the depreciation that we take on the interest during construction. That's something that we wouldn't have had if we didn't have debt. Okay, oops, Shift Control R, and then, oh, I was wrong. We get to deduct the IDC depreciation, and we get to deduct the interest expense. I added the interest we paid during the construction, so that was wrong. Okay, this is how much interest we get to deduct, and then we can compute the tax shield. Okay, and the tax shield, we'll put our tax rate here. Okay, and there is the tax rate. Excuse me. That's here. I'll multiply this by the tax rate. Okay. And we can then compute a couple of things. First of all, we can compute the equity, debt, and tax shield. And if we've done it correctly, which I doubt it will really work, it looks like it works in the first period. We take this one plus this one minus the tax shield. If I don't do that one more time, I'm going to go kind of crazy. That should be the same as the project IRR, which project cash flow, which it is so far. So far, not because of this one. And okay, is it perfect? I'm gonna pause. I hope I'm resumed. Yes, I'm resumed. The reason it was different was because there was the net operating loss carry forward, so I'm going to leave that for a minute. And why don't we just make one more calculation and call that the after-tax debt cash flow, which is really what you should be using as the basis for the comparison of the project IRR with. So that's just going to be our cash flow minus, yes, not minus, yes, minus this one. So that's, whoops, that's going to give us a little bit of a lower number. And then we'll put the after-tax debt IRR, okay, equal XIRR. Select the whole thing and select this one. And after we account for the effect of the taxes, our IRR on the debt is only 9% compared to our project IRR of 1.9. Let's make one more thing, and then I'm stopping the video. And that, I think it would be nice to make a graph of the debt service and the CFADS, okay? And I think one way, why don't we do it this way? Let's press Shift F11. Let's make a graph sheet. Okay. And here's one of the ways we could do it. Let's I'm going to be a little bit lazy. And let's put a year of the commercial operation date. So let's find our COD date and start with that year, not start with an earlier year. Okay, that means we won't put any of the construction years here. And then we'll put +1. So why don't we put the COD year up here, and then why don't we put the decommissioning year? Okay. And okay, and we'll put this as the year. Let's just drag that across. Now, the reason I'm doing this is because why don't we call raw year, and then we can compute the X scale. And for the X scale, we'll put equal if this is less than the how about less than or equal to the decommissioning year, then we'll just take the year. Otherwise, we'll take equal, and we don't have to put equal NA open close brackets. Okay, and what did I do? Okay, you see, that was kind of stupid. I didn't put the AI in if. Okay, Shift Control R, and I did it wrong because I didn't lock in. 1, 2, 3. That one. Okay, so it's the same, and then we have some NAs just in case we go further forward. And now CFADS, and we'll just do a sum if. Okay, do you remember the sum if? Click on this one, go all the way up to the year, press the F4, go back to our graph page, press the F4 twice, and then go to this page and find the CFADS. Okay, and then we'll go down and put the debt service. I hope. Okay, and This looks kind of bad. It looks like we have a DSCR below 1, which I don't think we did. So I've just about finished. One more pause. No, I guess. Thank you. Good.
There's skim milk on the cereal. Okay?
Mm-hmm. Okay. Thank you.
I've been eating enough.
Well, I should have something to eat.
What?
Eat something.
Do you want cereal?
No, thanks. Oh, yes, and publicity. If you would like to sign up for a course, go to financeenergyinstitute.com and there are, I think that the way these videos work is an excellent supplement. I'll speak much more clearly in the classes to the courses, but it's certainly not anywhere near a substitute.